The broadcast is now starting. All attendees are in listen-only mode.
Hi everybody, thank you for joining us. My name is Lisa Travers and I'm the one who sent you the emails. Today we have a webinar to present to you. Darren O'Brien from Alliance Corporation is going to present it. He is our Director of Manufacturing and he has a lot of experience with fiber optic cable. We've been doing this for quite a while, as he's going to say, so we've learned a lot and we're going to share that with you. During the webinar, everyone will be muted, so you won't be able to vocally ask questions, but there is a chat pane, so we encourage you to use that. If there's anything throughout the webinar that you'd like to ask, just type it in, and I will forward questions to Darren, and he'll typically address them at the end, so it just makes it easier to make sure all the material is covered first. We also did take note of all the questions that everyone submitted during registration, and Darren is going to try his best to cover those throughout the presentation. Quite a few of them we do cover anyways. The ones that we don't get to cover, we will work to follow up with you afterwards on those. And most people do usually ask me this question: are we going to hand out a copy of the presentation after? And yes, we will. After the webinar, maybe not immediately, I will be sending out a PDF of the recording of the presentation, and I'm also going to be recording this webinar. So what I'm going to do is upload it to something like YouTube. It's called Vimeo, and I will send everybody a link and a follow-up email to that, so you can watch it whenever you want to. It's always going to be there, and all of our other recordings of webinars are up there as well. So without further ado, I'm going to hand it over to Darren and talk to you at the end. Thanks.
Thanks, Lisa. Thanks, everyone, for taking the time to join us today. I'm Darren O'Brien. I'm Director of Manufacturing for Alliance. I've been in this industry, in the telecom industry, for well over 15 years now. And through that time, gained some quite a bit of experience in the AC/DC power system world, power distribution, solar power, cable assemblies, and fiber optics. Now, since my time with Alliance, I've been heavily into fiber optic assemblies and fiber optic material for the wireless industry. Who is Alliance? Alliance is Canada's largest provider of infrastructure products for the wireless industry. We've got over 500 people in North America. We've got engineering, sales, production people throughout North America, US, Mexico, with a strong commercial track record of success. We offer passive and active solutions for the wireless industry. We are innovative market leader of a number of firsts in fiber or composite cable to the tower. We are leaders in PIM detection and PIM mitigation, and have executed thousands of wireless builds throughout North America. Our headquarters is located in Mississauga. We have 2 manufacturing plants, one in Mississauga and one in Juarez, Mexico, and many warehouse facilities and sales throughout North America. Canada now has over 27 million cell phone subscribers today, of which many of us, probably 1 million, have more than one account. A work phone, a family phone, kids' phones. Many of us have a second one. And the population of Canada is 34 million, leaving roughly 8 million of us denying ourselves the pleasure of that annoying ringtone. What is driving this demand, or why the big demand? Technology is one, and innovation in portable devices such as Blackberries, iPhones, and tablets. Things like cloud computing are driving the demand. YouTube has entrenched itself as a dominant application on the mobile networks. They are now more than doubling the second highest ranked application during peak period at 31%. massive amount of bandwidth required. Music and movie downloads, apps, Facebook, home alarm monitoring, and so on. The demand for bandwidth is ever increasing, and faster internet access requires new technologies and new infrastructure advancements in order to handle this. Now, why the fiber to the tower? They're creating new next-generation fiber to the antenna architectures. These new architectures now have radios mounted on top of the tower, fed by optical fibers. And this solution provides an infrastructure that delivers digital RF over fiber signals, delivering significant performance enhancements, such as reduced power output requirements for the radio, increased capacity and coverage, and reduce overall footprint, increasing energy efficiency and resistance to noise, which also has the ability to pre-install future capacity with little or no added cost. However, installing these new fiber to the antenna systems with an operation focused on hardline coax, operators are facing new challenges. One is cable management challenges on the tower, planning and site walks, tower loading wind loads, fiber connectivity, and a major one, fiber handling and testing. In the early days of fiber to the antenna, designs for fiber and power cables were installed separately to each radio. And the initial deployment cost of this cabling solution is usually relatively low, but it provides no flexibility for future expansion. Every time equipment is added to the tower, new power and fiber lines are needed to be installed, and this method becomes far more expensive than others because of the cost of returning to the site and installing each separate cable. And then if that cable does get damaged, the entire cable must be removed, replaced with a new one, potentially increasing operating costs. Alliance has overcome many of these challenges by working with manufacturers in designing hybrid fiber composite cables and power trunk cables. Alliance was a winner of the New Product Innovation Award for development and implementation of one of North America's first fiber to the antenna deployments. What are hybrid cables, or what are composite cables? These are hybrid, they are cables that consist of fiber, DC cables, water blocking material, all wrapped into one jacket, eliminating the separate power and fiber. These cables provide a much greater flexibility for future expansions and lower capital and labor costs over time. Some of the configurations we've come up over the years is anything from a 2-conductor, 8-gauge consisting of 8 fiber, all the way up to a 10-conductor 6-gauge with 48 fiber. Many of these configurations are what we call an armor or shielding, consisting of either corrugated steel armor, copper tape, and sometimes a braided shield. They all consist of water blocking tape, and they all consist of a strength member in the units as well. The fiber and power cables, when they're manufactured, delivered to site, are typically broken out and terminated at one or both ends and fed into a distribution blocks or a separate plug-and-play modules. The plug-and-play modules, these work really well as there's no handling of the individual fibers, and they speed up the installation time. Modules are designed to lower wind load on the tower while preventing ice and snow buildup as well. These modules, they don't You don't need any special tools for installation or changes. Maintenance is far less expensive because of just a short jumper between the module and the radio is handled, leaving that trunk or composite cable as a permanent structure of the tower. An issue that comes up quite often we see is planning. Planning is very important, especially when we're trying to deploy sites in the field, especially in remote areas. We've seen on a number of occasions where a contractor has gone to a site to install cables and find out that either the cables are too short or they're too long. In a case where they're too short, that's where we wish we had the infamous cable stretcher. So if we have option one where the cable is short, the only option is pull the cable down, order a new one, wait for a delivery and reinstall. That becomes very painful and expensive. Option two is we have come up with a solution where that cable, the short cable, stays in place, and we have a kit where we supply. It's an outdoor kit. The box is mounted on the tower or on a shelter, and a short extension cable is from that box to either inside the shelter or equipment. We've had cases where the cable's too long, and we've been to a number of sites where because the composite is so big and so bulky and people are worried about damaging it, they just coil it up, stuff it under a desk or behind a rack. And this can eventually lead to damage on the cable. And a lot of this happens when the cable is terminated at both ends. To fix this solution, we've come up with what we call a slack box, where we can coil up any excess cable, store it in a box. The box can be mounted indoors or outdoors, and it protects that excessive amount of cable. And it also, for future, if needed, an extra length of cable, you know that you have it on site. So it's very necessary to plan before the site installation begins. This will keep costs in line. It prevents downtime. It'll prevent delays and or scrap. Now, there's always exceptions, and we understand that there's unexpected issues. Just know that if you have an issue with a cable, if it's too short, too long, you have other options rather than starting from scratch. Some challenges with tower and wind loads. With FTA moving toward a trunk solution, or composite solution, reducing the total number of cables needed makes it easier and faster to install. This reduction in cable helps to limit tower loading, and it also reduces space taken up in cable trays and within shelters. However, now that the radios are moved to the top of the tower, it is subjected to more snow and ice load, as well as a much larger wind load. One must make certain to factor in the proper ice loading considerations in new tower designs and ensure when retrofitting an existing tower that it can handle these new loads. Even if you're in an area that is not a high risk, it is always a good idea to include the consideration, thereby resulting in a much more conservative design. And planning efforts should be made to define future loading at the time the tower is initially designed or specified. Now, it's possible to make some modifications on an existing tower, but the ultimate tower capacity is limited by the consideration of the initial design. And it is also more costly to modify a tower at a future date than to build the capacity of the tower at the time of the original construction. Another major challenge is fiber connectivity. We've seen the evolution of coax to fiber, And many customers, installers, and contractors, they've mastered how to handle and how to install and the accessories required to support coax. Now that fiber is installed, there is a fear of fiber. It's fragile or it's too delicate. Fiber cannot withstand the pulling or bending force the typical coax can. But that's not true, not when we're talking about a composite or a hybrid cable. It is more the unfamiliarity of fiber. Training is key when handling fiber. Installing fiber or trunk solutions does require a new set of skills, and it does require a new set of equipment. However, if trained properly, you should not have any issues. We've partnered with the Fiber Optic Association and offer a number of courses from how to handle fiber to fiber certification approved by the Fiber Optic Association. And these classes are usually small 4-day programs. 50% is hands-on. Toolkits are provided. And many carriers today have made it mandatory that all installers handling fiber optics are to be certified. This is a study that was done recently showing the different causes for network failures. A leading cause of poor fiber performance is faulty or poor connectivity. Fiber connectors that have been contaminated, have been damaged, incorrectly mated, these types of connectors will prevent signal delivery. Good connector may pass today, but over time, if it's not inspected or cleaned properly, could fail. And I'm certain everybody's aware of this. Dirt is the enemy. 80% of all cable failures are because of dirt. Little microscopic particles and fluids, liquids, fingerprints. It is important to inspect the cable upon receipt to make sure no damage has happened during transport. It's important to inspect every connector prior to installation. It's important to inspect the ports that the fibers are being connected to as well. People think dust caps, if you're working with a clean fiber, put the dust cap on it, you'll have no issues. But dust caps, because of how they're manufactured, do introduce contaminants. Dust caps are only there to protect the fiber during transport and during installation. So it's always wise to inspect the fiber every time you remove a dust cap. And it's always important to check testing gear, launch cables and adapters prior to doing any fiber testing or inspection. Because if these are damaged or contaminated, they will contaminate and damage the good fibers. Alliance has terminated over 3 million LC connectors last year. We have a strict termination procedure, high testing criteria where we inspect not only the IL and RL, but the geometry of the polish connector. We look at the pull force on connectors and the glass itself. This ensures a high quality functioning cable is shipped to the customer or to the site. We'll warranty any cable that we send out, providing a few simple steps are followed. Now everybody should be following these steps no matter who manufactures the cable. This will just help ensure that you know anything you've installed was functioning at the time of installation. Prior to installing a fiber cable, a simple VFL light test. Perform that. It's still on the reel, still on the ground. Shine the light through it. This will ensure that all fibers are working, they're functioning. If no light in, light out. If light in, no light out, there's a risk that there's a broken fiber in there. Step 2, visually inspect the connectors using a handheld microscope. And here we're looking at the end face of the fiber connector. You're looking for dirt, you're looking for scratches, chips, that sort of thing. And if you do see those things, clean or repair the fiber. Inspect, launch, and receive cables. Test for IL and RL using power meter and light source. Re-inspect to ensure no damage happened during test and replace the cap. We then hoist the cable into place and repeat the same steps again. And then this is to ensure that nothing was damaged during the lift of the cable. And then make your final connections. And when making those final connections, make sure we're inspecting and the mating components that the fiber connections are being made. Like I said earlier, dust caps do introduce contaminants. Always inspect a fiber when the cap is removed to ensure a clean surface. Now there's, over the years and recently, there's so many types of fiber connectors out there in the market today. Many of these are dictated by the RU manufacturer. The majority of the connectors we are seeing and have terminated are duplex LCs. They're a small form factor, relatively inexpensive to terminate, and have a proven track record of being the most dependable in the wireless industry. Now with the demand for more fiber to reduce repairs and for future expansion running up the tower, we're starting to see the migration toward MPO connectors. The now traditional hybrid cables have a power connector or multiple power connectors with multiple LC fan-outs. And now we're starting to see the move from that to one connector, one MPO connector. And with the evolution of the RUs, we're certain that we're going to see more MPO connectors terminating directly onto the radios, moving away from the LCs. One hand, this is good news, as it's going to reduce the size of the hybrid breakouts and make installation much quicker, but it will require those installing, training to handle, inspect, and test, and will most likely require some equipment investment as well. We've seen a number of cases where the complaint is the fiber is not working or the fiber is not working well. In many cases, it's just a dirty connector, and all it needed was a simple cleaning. We've gone to the field in some cases only to find the test equipment has not been inspected or maintained. Poor launch cables, poor receive cables will fail a perfectly good fiber. Damaged launch and receive cables will damage a good connector, and we've seen test gear that has not been programmed with the correct settings. Always inspect and always clean launch and receive cables prior to each test. And you see, I've kind of said a few things repeating things over and over again, and I do this and they're simple things, but it's these simple things that cause major issues when trying to deploy a site. Good cables behaving badly. We've been to site, we've seen cables catch fire, and this was because the cable was live. We went to this site, this one site, we were there to repair a cable. The climber climbed the tower to drop the top end of the cable down, but did not disconnect it from the equipment at the bottom. So it was still a live cable, it shorted out, the cable was caught fire. Always ensure when handling power cables, any cable, that it is disconnected from the power source. Alliance, we've supplied 60,000 trunk assemblies over the last year with only 0.0001% return through our RMA process. And over the same time, we've produced and supplied 150,000 fiber jumpers. And we've seen a 2% return through our RMA process. And we had kind of asked ourselves, why are we seeing the delta? Many of these are proprietary connectors where we just purchase, we cut in half and terminate with our own connectors. When they're tested in-house, and we know they test well. So the next question is, well, how are they handled when installing in the field or at the top of the tower? We ended up going to a few sites to find out how these were being done. And we watched the installer put on his belt, safety harness, he's got some jumpers hanging off his belt, and he climbs the tower. The radio's already mounted to the top, and he gets to the top, pulls out the fiber, and he starts to plug in the fiber. But he's not looking where he's connecting those fibers. He's connecting them blindly. And it was at that point that the fibers were being damaged. There's no issues with the trunk. It tested well. It was installed. It was tested. Now we have jumper here, and they're fighting to get it in. They do get it in. They climb down. They start to power up the system, and things are failing. Why was it failing? The fiber was being damaged as they were making that final connection at the top. So we suggested installing the jumper into the radio on the ground prior to hoisting up. That way they are not reaching blindly trying to connect the fiber. This ended up dropping the RMA rate by 1.5%. That's pretty significant. Cleaning a connector. There's a number of ways in cleaning connectors, and a number of customers and contractors have their own ways of doing things. I'm just going to go through a couple of them here. Using a dry approach method, we don't recommend. A number of contractors do use this. But when using this, contaminants on that fiber surface may scratch the fiber as you wipe those contaminants across the surface. There's the wet-dry method, which we recommend, and the wet-dry method helps to lubricate these particles to prevent any scratching as they're wiped off. Then, of course, there's the wet method, wet-only method. This is good as long as you follow up with a dry method, but if you just do a wet-only method, it will leave a residue after the alcohol or solution dries, and this will leave a haze or some residue, which will lead to a poor performing fiber. The little trick of the trade, there's some contaminants out there that alcohol or some solutions will not get off. I mean, when we look at fiber, it is glass. So if you do have an issue getting a contaminant off, trick of the trade is Windex. Spray on a little Windex, wipe it, follow up with a dry method, and it will usually get those hard to get contaminants off the fiber. A clean connector. This is a picture of a good, perfect, and I mean perfect connector. There's no scratches, there's no chips. This is what a lot of people expect or want to see. Is it, with the standards out there today, you are allowed some chips, you are allowed some scratches in certain areas. Never through the core of a fiber, but outside of the core and on the ferrule, you are allowed some small scratches or imperfections on the fiber. Here is a picture of an end face contaminated with dust particles. Now, if this is not cleaned and mated with a good connector, it is going to leave a gap between the two connectors. And it may pass today because you can see there's nothing in the core of the fiber. But over time, because of that gap, more particles and contaminants are going to flow or seep into that gap and eventually cutting off that light, which will eventually and over time fail. Here's some pictures of a end face that has been connected to another good connector, and you can see the bead of rings around the outside where the connectors are making the physical contact. Over time, when this liquid dries or dissipates, it before it dissipates, it's going to attract some dirt and debris and particles. The liquid will dry, and over time it will fill in and eventually fail the fiber. So it is very important to make sure that all liquid is removed from the end face of the fiber. Spit polishing doesn't work. And when we've been on site, when we've watched some people actually spit on it and wipe it on their shirts, and that just doesn't work. This is just a diagram of when we're in our manufacturing, what we're seeing and what we will pass, what will fail, what we will send back for rework. So this is just looking at a single mode connector. So after we polish our connector, we visually inspect, and we go through each of these panes here. If we have some deep scratches, broken fibers, imperfections, automatically they're failed and they're sent back for retermination. If we have some light scratches, a little bit of polishing debris, some chips on the back, we're able to possibly repolish or touch up these connectors through polishing. So they will be returned back to the production and be touched up. What we are looking for is what we see at the bottom that are acceptable. Some scratches on the outside on the ferro, on the ceramic, a little bit of debris, some chips, and ideally the perfect end face where there's no imperfections on the end face at all. Fiber handling. This is probably a major one on how we handle fiber. Minimum bend radius from one material thickness is not the same as another material thickness. Fiber optic cable has a minimum bend radius. It's typically specified by the manufacturer for loaded conditions during cable pull and for unloaded conditions when the cable has been installed and in its final resting place. When no bend radius is specified, one can usually be safe in assuming a minimum long-term low-stress radius not less than 15 times the cable diameter. Now, bare fiber can be wrapped around a pencil and not break or damage. When thinking about bend radius in a cable, you must look at the whole package. If we look at a composite or a hybrid cable, we've got 6 conductors, 6 gauge, we've got subunits of fiber. That's going to be a rather large bend radius of about 20 inches. Where if we look at just a fiber-only cable, armored possibly, we're looking at a bend radius about 5 inches. So it's when we look at the bend radius and look at installing, always ensure that you know what these bend radiuses are. Hoisting grips should always be attached a minimum of 5 feet away from the end of the cable or breakout. Always hoist the cable with the manufacturer's provided nylon sock or protection tube. And this I'm talking about, we typically use a tube or a nylon sock to protect the breakouts. So the fibers and LCs are not flopping around. Everything's contained in one neat little package. And this is for the protection during installation. Always test and inspect the cables once the installation is complete. And it is important to keep copies of all tests on file. This is your way to prove that when the cable was installed, it tested as per the manufacturer's recommendations. Make sure fiber connections are seated firmly in its mate. When we use an LC duplex connector, when you mate it with its mate or in an adapter, you will hear an audible click when it's seated properly. If these connectors are not connected properly, the test reading will have a high loss or may even fail the cable. And we've seen in a number of cases where the cable is returned only to find out there's nothing wrong with it, and through trial and error, it ends up that there's an issue with the mating connector or adapter. That's why it's always important to check and inspect mating connectors and adapters. We've seen many issues arise from people testing in the field Many people do not know how to handle or properly use the testing equipment. Manufacturers of equipment will usually provide training on their own test equipment. Sometimes they're not very helpful. We have had people and do recommend people bring in their test gear to us. We'll inspect it. We'll verify it's working properly. We'll teach them how to operate and understand the results that they're getting from the equipment. The use of incorrect settings and modes. We had an issue a year ago where we were shipping a ton of cable out to the customer, and they claimed everything was failing. We ended up flying out, going to the site. We found that they were inspecting connectors with the microscope, which is good. We recommend that, but soon found out the gear they were testing, the software that was being used with the microscopes was set to multi-mode, where we were shipping single-mode cables. So because of something very simple, the customer was saying everything was failed when it was so far from the truth. Once we corrected the setting, everything passed fine, no issues. Launch and receive cables that are poorly handled. Many people think that when they pay top dollar for a launch cable or receive cable that it should never fail, when that's false. If not handled properly, after a number of matings and testing connectors, the connectors will wear, they will chip, they will break. I mean, it's the same glass as what the cable under test is. These do have to be repaired, either cut off, new connectors added, or repolished. The cable itself will last a long time, but the connectors will always need to be repaired. And Alliance has repaired and replaced many of these over the years. Many people are unable to understand the final test results, the paperwork or the documents that the equipment spits out, and especially with OTDRs. Have the proper tools to do a job. A good time and money saver in testing fiber on a reel before hoisting is using a VFL. Look for visible signs before you use the VFL. Always look for visible signs of damage, like cracked, broken reels, kinks in the cable, maybe dents in the cable. And then we'll use a VFL, or a visual fault locator. Simple LED light, and sometimes a laser light. Shine it in one end, and it should come out the other end. If no light comes out the other end, typically means the fibers are broken. Microscopes. Fiber optic microscopes are used to inspect connectors' quality and diagnose problems. We're looking at the end face of a connector. With these, there's software programs that run parallel that will give a pass-fail. Make sure the correct settings are in there, depending on the type of fiber you're using. The software is able to pick up little imperfections that the human eye may not see. Make sure the correct settings are made, and remember to check that there's no power present in the cable prior to doing the microscope checks. Protect your eyes, folks. We only have 2 of them. Now, due to relatively short lengths of hybrid or composite cables installed, the best piece of equipment required to test is a power meter and light source. And really, it's the only one stated in the telecom standard to certify an optical fiber. Multi-mode fiber loss measurements must be made using an LED source, whereas single-mode fiber loss measurements require a laser source. This equipment gives you a far more accurate value than an OTDR will. They're less costly and much easier to handle and understand. Optical time domain reflector, OTDRs, typically used for testing long distances with multiple connections or splices. Works well to determining where a fault is in a system. Now, the OTDR does have a great deal of difficulty resolving features in short lengths of cables and will likely show ghosts from reflections in connectors, and this is where it confuses the user and gives false readings, failing a cable. Only those who have a great deal of experience and understanding how the OTDR operates should use these. Now, these are great pieces of equipment, but you must know how they're operating, how they're getting the results from the tests in order to perform the test properly. When deploying FTTA sites, we know managing materials, it's a nightmare. You could be dealing with up to 20, possibly 30 equipment and material vendors. There's always at least one item missing in order to complete or to ship or complete a site, and which requires 2, 3, or 4 visits in order to complete, increasing labor costs and delaying that deployment. Alliance deals with hundreds of vendors and suppliers. We've worked with many customers where we manufacture the hybrid trunk cables. We'll kit it with the necessary hangers and accessories, as well as other materials, antennas, pin-tested jumpers, and customer supplied material. We'll build it all into a nice little kit, and that kit will ship directly to the customer or directly to the site. And by doing this, eliminates delays in the field, eliminates multiple site visits, scheduling is easier to manage, and keeps the overall project costs in line. And if needed, we'll even warehouse the goods until the site is ready deployed. Some recommendations. Fiber training that covers splicing, connectorization, and testing is key when handling fiber. If you must understand how the fiber is operating, how it is handled, how it is terminated, and be trained on why all these things are happening. Field installable connectors, they work, and they work in a pinch when you have nothing else. But we don't recommend it. We recommend splicing a connector rather than a field connector. And we do this because of experience. Some people can install a field connector, no issues. But an inexperienced person, because of the index matching gel that's inside those, and when they're inserting a fiber, when they pull it out trying to line it up, they tend to take away or eliminate some of that index matching gel. And then once they make that connection and make it permanent, it may test perfectly and well today, but over a period of time, once that index matching gel settles down, it may fail that cable. Well, we recommend a splicing, and the splicing, you know what the loss is on that existing cable, and splice it on, and there's minimal loss on that cable and splicing. Always follow the installation guide from the manufacturer on whether it's installing and hoisting cables, whether it's mounting equipment. Always follow those guides. Those guides are there for a reason, on how to properly install it. It's there for your safety. It states guidelines. It's very important to always follow installation guides. Purchase and maintain and use the right tools for the job. Fiber handling is important. It's not like pulling a piece of coax cable. Once you have the understanding and understand how to handle and manipulate fiber, you shouldn't have any issues. And then what we've seen in the industry is when fiber was starting to be deployed to the wireless world, we were getting calls daily because of issues. And a lot of it was because people didn't know how to handle it. They were handling it just like a coax cable. So it's key for when we talk about training, fiber handling is part of that training. And inspect, clean, and inspect every time a cap is removed from a fiber connector. And planning is very important. Now we are coming up, we've made a few videos the last few weeks. We're just going through our editing. Once those are completed, these videos, they consist of fiber handling, they consist of fiber cleaning. We have videos on fiber testing using the OTDRs and fiber testing using power meter and light sources.
Sorry.
Once we're finished with these videos, we'll get them out to the people, and Lisa will probably be leading that charge. I don't know, Lisa, if you can touch on that a little bit more.
Yes, actually, sorry, there isn't one on the OTDR. We've created 3 video clips, one on our recommended cleaning method for cleaning fiber, another one on how to test insertion loss, return loss, and a third on how to test for continuity. So they are in the editing process, and as soon as they are finished, I will be posting them to, I think, YouTube. So I will be sending out a follow-up email to this webinar, and once the videos are ready, I'll send everybody a link to where they can watch the videos. They're going to be really helpful. So thanks, Darren, for the presentation. As I said in the beginning, I have recorded this webinar, so I will be sending out a link to everyone. If anyone has any questions, I haven't seen any come in. There's been one, but we're going to follow up after the webinar. If you do think of anything else after the fact, just send us a note. We have no problem. And like I said, we have a lot of other resources that we can help you or put you in